All right, so we're going to make, girls, a foaming eruption. This is different than the elephant toothpaste. It uses a different mechanism, okay? So you're going to each do parts.
Okay.
And they gave us lovely pictures to follow. Okay. Natalie, you're going to do the first part. In this cup, the directions want 1 big spoonful of anthocyanin. Okay.
Anthocyanin.
So, yep, you're going to open this guy up.
Is it gonna squirt?
Nope. Okay. It's a red powder. So you take it.
Powder.
Okay. Fill up the cup, and then dump it in the plastic cup. Or fill up the measuring spoon. Keep going. Keep going. Fill it up.
That looks a little black.
Okay. Dump it in. Good. It's got some static electricity. Look at that. Sticks to the side. That's okay. You can set the spoon down.
That's cool.
Okay. Then it wants 20 milliliters of water. How big is this syringe?
10 millimeters.
Milliliters, right? So how many times are you going to have to fill it up?
2.
Okay. Nope. Annie, you're going to do a different job later. Natalie's doing this part of the job. Okay. Yep. Pull up till you get to the 10. Keep going, keep
There's
going.
a 12.
Okay. Then, yep, carefully squirt it in your cup. Okay. Do it again.
We're making a stew.
Careful. There you go.
1, 2. Now I see the red in it.
Okay.
Oh yeah.
Now does it look red here?
Red bubbles.
Okay. Stir that up, Natalie. Mix it up good. Mix it all up so you want the powder all dissolved in it.
I'll hold it. Thank you.
How does it feel? Pretty dissolved?
It looks a little purpley too.
You might look and see.
Might do a little bit more.
I think you're okay.
It looks a little purpley.
Okay. This next part, so we're going to set that aside for now.
Uh-huh.
The next part's for Hannah.
Okay.
Hannah, in this flask,
Uh-huh.
you're going to put in 2 things. This first one is citric acid.
Uh-huh.
They want the whole bottle. Okay?
Okay.
Get it all in there. Yep, dump the whole thing.
It sort of looks like salt.
Yep, it's just a white crystal powder. Okay, good. Then, this one is sodium carbonate. They want the whole bottle of this.
Okay. It looks a little like it.
Yeah. Alright. Down empty. Good. Okay, now don't put your gloves in your mouth. Okay, now you're going to swirl it, Handy, to mix those powders together equally. Yep. There you go.
I'm sorry.
So, citric acid is an acid. The sodium carbonate is a base. In the dry form together, they don't do anything together. They'll sit like that all day long. Nothing will happen. Okay? They need water from Natalie's to react. Okay? And then the red that you added, Natalie, the anthocyanin, is just a food coloring, essentially. And it comes from grape skins.
Cool.
So that purple is from red grapes. Okay? So, Hannah, take your flask, set it in the bowl. Natalie, do you think you can pour into there?
I'll try.
And then, oh, hold on. I forgot one step. We wouldn't have any bubbles. It would react, but we wouldn't have any bubbles. We need to put some dish soap. That's all that's in here is just liquid dish soap.
I like bubbles.
We want the dish soap.
It's clear.
Yep. This dish soap is going to capture the gas, the carbon dioxide. Just like when we make elephant toothpaste, right? We capture the gas with dish soap. So that dish soap's just capturing the gas. Okay, now Natalie, take
Pour
your
that in.
your dye and dump it in.
Be careful.
Dump it, dump it, dump it, dump it. Okay, I did.
It's purple. How cool. Cool.
So now you got purple
It's
and
going all
blue
over.
foam going all over.
The white really stands out. Why does the white turn into blue?
Well, okay,
just a
so
little.
this dye, anthocyanin, will react in 3 different colors. It'd be like a reddish purple, or pink, or blue.
Ooh.
In an acid, so our citric acid,
Yes.
it turns red and pink. That gives you kind of your purple colors, right?
See them getting so down.
In a base, our sodium carbonate, it turns blue. So in this case, we're getting flecks of blue, we're getting purple, we're getting reds, because you have acids and bases in there.
Cool. Cool.
Mhm.
Is it hot or cold or something?
This one doesn't give off any heat. It's not exothermic like the elephant toothpaste.
Okay.
And all we're doing was we're capturing the carbon dioxide. Okay, so looking at the chemistry, we start out with citric acid and sodium carbonate. Citric acid is H3C6H5O7, which means it's got hydrogens, carbons, more hydrogen and oxygen in it. And then we added water, the H2O. The sodium carbonate was Na2CO3, which is sodium and carbon and oxygen. When we add the water, that's when they start to break apart. And we end up with the hydrogens pop off. So we have 3 hydrogen atoms, or ions. And then we have a citrate anion. So the C6H5O7. It has a -3 charge because we popped off the positive hydrogens. Over here on the sodium carbonate side, same thing happened. The sodiums pop off. So we have sodium cations. Those are positive charge. And then we have the carbonate anion, which is carbon and then 3 oxygens, so it has a -2 charge. They're not happy being negatives, and so we get a next round of reaction. We take the hydrogens from this side and the carbonate from this side, and it forms carbonic acid. So it pulls 2 hydrogens and then the carbonate. So those 2 hydrogens make this back to a 0 charge. But this is a very weak combination. So it breaks down very easily, and it breaks down very quickly into water and carbon dioxide gas. So all this reaction was taking place. They broke apart, then the parts joined together, then they broke apart again, all in that foaming reaction.